Okay, so let's knock out one more average speed problem here where minimal information is given to us. So in this particular scenario, you have a car going from A to B at some unknown distance at a constant rate of 30 miles per hour, but on the return trip from B back to A, it is moving at a faster rate of 55 miles per hour. And the question asks us to find the average speed for the entire trip, so there and back, or round trip in this case. All right, so let's go ahead and set up the information using our load chart here. So here I have it split up into three different segments, segment 1, segment 2, and the total trip, since that is what is being asked of us to perform. Okay. So let's go ahead and plug in values here that we know, and then we can kind of wiggle our way through this particular problem. What I do know for the first segment is that it is moving at a rate of 30 miles per hour. So I will go ahead and substitute S average 1 there for 30 miles per hour. D1 got changed to just D because for this particular problem, it's important to recognize that the distance there and the distance back is the same quantity, so there's no need to use subscripts. So good habit, label D1 to start, but then recognize stuff as you approach these types of problems. So D in the numerator there, and then T1, I don't know how much time that took because I don't know the distance. So it's okay to leave things unknown and then wiggle your way through the problem. I can use the same strategy for segment 2 here. I do know that on the return trip, the car is moving at a rate of 55 miles per hour. Again, D2 just got turned into D because the distance there and the distance back are the same. So I'm trying to minimize the amount of subscripts when appropriate. T2, I don't know. Let's keep that also an unknown. Let's focus on what the question is looking for, though. It asks us to find the average speed for the total trip. So we need the total distance and the total time. But we can substitute D total for D plus D, which implies the distance there and the distance back. So therefore, we have two D's in the numerator. Okay. T total would just be whatever time it took to go from A to B, and then T2 is whatever time it took to go from B to A. So that'd be just the sum of the two different times there. All right, and as you can see here, we have a bunch of unknowns. We have D in the numerator, we have T1, we have T2. So we have three unknowns. So let's go ahead and start slowly chopping these things down, and then let's solve for the total average speed. Okay, so first you should recognize is that because we don't know D and T1 and T2, what we can do is utilize information in segment 1 and segment 2. Here I've chosen to substitute out T1 and T2 in the denominator on the right side of the column. So using the information in the first segment, I can solve for T1 simply by multiplying both sides by T1 and then dividing by 30 at the same time. So you should have the statement. So therefore T1 is simply D divided by 30. And then the same process can be used for segment 2. T2 would simply be D over 55. So now I have an expression for T1 in terms of D. I have an expression for T2 in terms of D. What I could do next is that we can substitute in for T1 and T2 in the denominator for the total trip. So let's go ahead and do that. Okay. I went ahead and simplified D plus D to give us 2D in the numerator. You can leave it as D plus D if you like, but I think reducing it down to 2D is a little nicer to look at. And then substituting in for T1 from the segment 1 information, which is D over 30, and then T2 is substituted in for D over 55. But you notice in the denominator you have two fractions, and then these two fractions have different denominators, so therefore it's important to find the least common multiples between 30 and 55, which happens to be in this case 330. So if you do that properly, you can multiply the left fraction in the denominator by 11 on top, also by 11 in the denominator, which yields 11D over 330. And then you can multiply the numerator for the right fraction by 6. So that'll be 6D in the numerator, and then 6 times 55 is 330. Now we have a common denominator for the bottom fractions. Therefore, we can just combine the numerator. So 11D plus 6D, that'll just be 17D, and then put that over the common denominator, which is just 330, which is what I've done here. However, at this particular junction, you notice that we have 2D divided by 17D over 330. There's a d in the numerator and there's a d in the denominator. That will cancel out. But in math, anytime you divide by a fraction, you have to multiply by the reciprocal. So the 17 over 330 gets flipped. So therefore 2 times 330 gives us 660, and then the 17 stays on the bottom. So if you do that properly there, you should get a value of about 38.82 miles per hour. So you notice here we started off with a bunch of unknowns, but you just have to learn how to kind of start trimming things down and substituting quantities in for statements that are true or that you know. All right. What I would like to address lastly is this misconception. Sometimes kids do physics improperly. Do not simply just take 30 plus 55 and divide it by 2 because there are simply two numbers. So this is a big no-no. As you can see, if you do this, you'll get 42.5 miles per hour, which is not close to 38.82. So do not carry this misconception as you practice these types of problems. All right, I hope that helps.